Hello students, welcome to Organic Chambers YouTube channel. In this video, I am going to tell you how to solve the given question in two methods. First, let's read out the question. The molecular formula of compound A is C15H24. Ozonolysis gives the following compound and formaldehyde, which could be compound A. You already know the molecular formula of compound A and you know what is the structure of the final product, and also you are getting formaldehyde as a byproduct. First thing I am going to do is, the first method is make use of the product given and then try to find out the reactant. This is called as retro analysis. Why retro? Because you are going in a reverse way. You know the product, based on that you are finding out the reactant. So how to do that? Now look at the product structure. You can see that there is a double bond oxygen here. How do we get this? Based on the ozonolysis on this carbon. That means what? In the reactant, I'm talking about only this part, okay? You have to do it bit by bit, only then you will get the answer, okay? So now you are supposed to have a CH2 group here. Why? Because on breaking this will become a formaldehyde, HCHO. What about this? It will become the carbonyl, that is oxygen, right? Now let's move on to this part. You see that there are 1, 2, 3, 4 carbons here, 1, 2, 3 and 4, right? And what about here? We have only one carbon. So there is carbon, oxygen and hydrogen, like this. Now we know that in ozonolysis the carbon-carbon double bond will break and it will form a carbonyl. That means what? Here and here the bond is breaking. That means what? 1, 2, 3, 4. 4 carbons must be here. 1, 2, 3, 4, like this. Between this carbon and this carbon there has to be a bond. So how do you write that? Between this and this there are 2 carbons where the bond must be 1 and 2. 1 and 2. But what about this methyl? This methyl must be on the second carbon here, like this, right? So that means what? When I break this open, this is going to form an aldehyde and this is going to form a ketone. And just observe, where do we have it? We have this particular molecule in option A. Therefore the right option is A. Okay, what is the other method of doing it? If you are very much familiar with the ozonolysis, how to break the double bond, etc., without writing the structure of the products, you can easily predict what will be the product. That means what? You have to check for each and every option. Do the ozonolysis on each and every molecule given in the options and then do it. So let's get started with option A. So you are supposed to break the bond here and then here, then check whether the product formed is yes. We have already verified it, but let's check for the option B. You can see that the bond is breaking here, that's right, but the double bond is here. That means what? It's not as given in the product, so it cannot be B. It cannot be B. Let's check for C. Here the double bond must not be there. It has to be endocyclic, not exocyclic. Therefore you can eliminate it in the first step itself. Now check here, same as this. So this is also not possible. Which is the right answer? The right answer is A. So what are the two methods? You already know what is the product. You check the retro. That is the first method. The second method is check for each and every molecule what will be the product, and if the product is matching it, what is given in the option. That is other way. Usually I prefer the retro method because it won't take much time to verify the answer. Thank you for watching this video, and if you have any doubt or if you want me to solve a question, please comment in the comment section so that I can solve that example. Thank you.